Hi, welcome to Redox Academic Tutorial. Today we are going to be considering a leaving certificate exam, chemistry higher level. And today we are going to be doing questions under volumetric analysis, which is also known as what? Quantitative analysis. And here is a question on it. They said a student carried out an experiment to determine the iron content of an iron supplement tablet. So the aim of this experiment is to determine the iron content in iron supplement tablets. So we have to determine the amount of iron present in a tablet, which is known as iron supplement. Now, 6 iron tablet was used. 6 iron tablet was used, and then this iron tablet was weighed to be 2.496 grams, and they were dissolved in sulfuric acid. The solution and the washing were transferred to a 250 centimeter cube of volumetric flask and made up to a mark using the ionized water. Now let me explain these steps before we go on. What is happened is that what the student does is that these 6 tablets was weighed into a crucible and they were pounded. Sometimes it's needed to be pounded. Sometimes you can add acid directly to the tablet, but it is advisable for you to grind the 6 tablets in order to have an increase in surface, because when you have an increase in surface, the particles will be able to interact with the solvent, with the sulfuric acid and then water, so that you can have a good dissolution of the iron content. So the student probably might use crucible, and then after that he add it to the what? So he add it into the beaker, and then into the beaker. So we have the ground one here, and the sulfuric acid was introduced. Definitely sulfuric acid was introduced, a little bit of sulfuric acid was introduced to dissolve it with I guess it's going to use stirrer, a glass rod, to stir this for even a distribution. Then after this was dissolved with a sulfuric acid, don't forget this grounded tablet was dissolved in a sulfuric acid and then stirred. Then it was transferred into a 250 volumetric flask. Using a funnel. It's advisable to use a funnel to avoid any form of spillage. So using a funnel. So this should be 250 centimeter cube volumetric flask. So this was transferred. I know everything will have been uniform now. Maybe you are getting color light green color, because supplement, the iron content is likely to be green in color. Because it might have other ingredients. The green might not be evident, but iron 2 sulfate tends to be green in color. So this was marked up with water, with ionized water. So meaning that the ionized water was introduced to rinse everything. The ionized water. This is just a representative of what is happening in the practical. So now I have a wash bottle just as a representation, was used to rinse the side of everything. So this is what it do. There was a grinding, there was a dissolution in H2SO4, and then the marking up with the ionized water to get 250 centimeters. So this is the process of producing the dissolution at the first stage here, to this point. Now the next thing was that the dissolutions, a 25 centimeter cube portion of this was transferred into a conical flask. So 25 centimeter cube of this portion here that was obtained after it was being, because this will be inverted several times to get a very dissolved solution. So this we are going to have after being inverted. After being inverted, we are going to have a complete dissolution. Just want to ensure that we are going to have a complete dissolution of iron 2 tablet. Then, and we are told that out of this were pipettes. Now 25 centimeter cube were measured, like 25 centimeter cube were measured into a conical flask. So meaning that from here, the next stage was that in a conical flask, this is a conical flask, which is also known as Elmeyer flask. So what was used to do this was a pipette. What we mean by a pipette, it's going to be one of the questions. So this pipette, there is something we call pipette, a volumetric pipette. It looks like this. Yeah, this was what was used. And then definitely this pipette, we have what we call a suction bulb, or a pipette holder that can use to withdraw the water. So we can use this 25 centimeter volumetric flask was used to transfer some of this solution about 25 centimeter cube, because this is a fixed mass. The pipette has 25 centimeter, is a fixed volume pipette. It has 25 centimeter cube range. It can measure up to 25 centimeter cube. So it's a 25 centimeter cube pipette. So, and because of that was transferred, 25 centimeter cube of the solution was transferred into what conical flask. So now after the transfer, what are we asked to do again? The solution, 25 centimeter cube of portion of this solution was transferred into the conical flask, and some sulfuric acid added. Now what was introduced here is that sulfuric acid was introduced. And I will tell you the aim of that sulfuric acid. The essence of adding this sulfuric acid is that it prevents the iron 2 to get oxidized. You know, I told you that what iron 2 is usually, iron 2 plus is green in color. But if sulfuric acid is not added, there is tendency for it to what? Change to what? Color brown. To change to color brown, Fe3 plus. This is green in color, F2 plus is green in color, but this one is brown if sulfuric acid is not added, because iron 2 tends to oxidize in the presence of air. So to prevent the oxidation, they have to put what? Sulfuric acid. So the essence of the sulfuric acid is that to prevent oxidation. So by adding what sulfuric acid, this maintain its state being iron 2. So this is going to be iron 2 plus. So the essence of sulfuric acid being added is to prevent oxidation of iron 2 to iron 3, so that the color will be maintained and the freshness of the solution will be maintained as well. So now the solution was titrated against standardized solution. Now this is where the titration now comes in, the word titration. So I would quickly like to draw the titration process. This is a burette. Introduce. Now it is clamped. Definitely it's going to be clamped. So, and then this solution was brought. And then here we have inside there we have KMnO₄ is always purple in color. It's purple in color, KMnO₄. And then we have our green, which is what? is iron 2 solution. Iron 2 solution is usually iron sulfate. Iron 2 sulfate. Let me just write it like that. So now, what happened here is that this sulfuric acid also prevent the KMnO₄ from going to oxidation number 4, because this KMnO₄, the oxidation, another thing that this sulfuric acid also does is that it prevents Mn2 plus, Mn7 plus, because the oxidation number of what? Of manganese here is +7. And when you are carrying out the titration, there is tendency that if you don't add acid, sulfuric acid, prior to the titration, there is tendency that also this manganese what? +7 can oxidize to +4 instead of, can oxidize to what? +4 instead of +2, can reduce to +4 instead of +2. The aim of this experiment is that the manganese +7 should be reduced to +2 and not +4. So the sulfuric acid help both the oxidizing reagent and the oxidizing agent and the reducing agent to maintain their state. Now, for instance, the sulfuric acid help to keep the iron at +2, and it maintains the reaction of the titration with manganese to reduce from +7 to what? +2, not +4. So the sulfuric acid helps us to eliminate this to happen, but it allows this reaction to occur. So these are the things that you need to know about these titration processes. Number one, KMnO₄ is the oxidizing agent, iron 2 sulfate is the reducing agent, and to ensure that the titration go on appropriately, we use sulfuric acid to maintain the reaction, to guide oxidation of iron 2 not to occur, and then to make sure that the reduction of manganese +7 is to +2 and not to +4. So these are the things that you need to understand about the reaction. And here is the equation for the reaction. We can see manganese 7 here has changed to manganese 2 plus, and iron 2 here has changed to iron 3 plus, which what want to happen at the end of the reactions. And these are the process that is involved in the practicality of the reaction. So let me check my camera that is going on. Okay, so I haven't been able to explain the process of the titration. Now let's go into the work itself. Now the question says identify a standard that students could have used to standardize the solution of KMnO₄. Now these are questions based on the knowledge of what you have on standardization of volumetric analysis. Now, what we are trying to do in this experiment is to detect the amount of iron in the iron supplement tablet. And to detect the amount of iron, that is the quantity of iron, you must use a standard solution, a reagent that is of known concentration. So KMnO₄ is a standardized reagent, and they are not asking what reagent, what primary standard is used to standardize the KMnO₄ that you are using as a standard to determine the iron supplement. So it's as if they are asking you, okay, what are the reagents, primary standard used to ensure that the reagents you are using is being standardized. So, and there are a lot of reagents, there are a lot of chemicals that are used to standardize KMnO₄, because KMnO₄ itself is an unstable compound, and to make it a standard, you must standardize it. And one of the compound is, you can use oxalic acid. Oxalic acid is a very stable compound. One of the attributes of a primary standard is that they must be very stable, pure, and they did not absorb water or what, they didn't absorb atmospheric water, they didn't absorb water from the atmosphere, they are not hygroscopy. So, and oxalic acid and or sodium oxalate has these properties. So they are a white crystalline solid. I'll put the picture on the word. They are white crystalline solid which when dissolved in solution, they can be used to standardize KMnO₄. They can be used to standardize KMnO₄. So we can use number one oxalic acid or sodium oxalate. Another one that can be used is they can use potassium dichromate. What? Potassium dichromate 7, I think the potassium dichromate 6 K2Cr2O7 can be also used to standardize KMnO₄. So these are the things that you need to know. Number one, oxalic acid. Number two, sodium oxalate. Number three, they can also use what? Potassium dichromate what? 6 solution. So these are the things that you can use for. So that has been answered. Outline the correct procedure for bringing the solution in the volumetric flask precisely in 250 centimeter cube mark. Now, what are the correct procedure? As I told you, for bringing the solution into 250 centimeter cube. Now, after you have dissolved these tablets inside sulfuric acid, the best procedure of bringing outline the correct procedure for bringing the solution of volumetric flask precisely into flask. The best solution is to use funnel. You can see, use it funnel. Put funnel in the volumetric flask, and then use your beaker to transfer this first, and then you can now bring your water in, or the ionized water. And when you see that you are about to get to 250 centimeter cube, always use the deionized water from the bottle, so as to make sure that the water added does not exceed the meniscus. We call this place meniscus, the meniscus point. Meniscus. So it must not be above the eye level, it must be at your same level. So meaning that the water you added to the solution of tablets in sulfuric acid to make it mark it up to 250 centimeter cube must be added in such a way that it does not pass the eye level, the meniscus level. So in order to prevent excesses, you use what? You use the deionized water from the wash bottle, as it enable you to add the water drop wisely. So these are the things that you need to consider. So number one is you are going to transfer the solution into the volumetric flask using what? The beaker and funnel. And when it's about to get to the mark point, you are advised to use the ionized water from the wash bottle, and add the water just twice until it gets to eye level. And after that, you must invert it to get a uniform or evenly distributed ion solution. You must invert. Put the cork. There must be a cork on this. Put the cork here. There's always a cork, and then invert the solution several times, maybe up to 6 times, in order to get evenly distributed before you pipette anything for titration. So that's it. So that's how to outline the procedure. Then explain why using more than one tablet. Why do we use? Because you can see we use 6 tablets. Why do you use more than one tablet? The first thing is that to increase the mass of analyte, you must be able to have a reasonable amount of analyte that you are using in the reactions, in the titration. So that's why it is considered to use 6 tablets for increase in the mass of analyte. Number 2 is that it gives you the data is well represented when you use 6 tablets, because we are using average. Number 1, like you are trying to get as much as analyte, you are trying to get as much as analyte to be used, and using the average of the 6 tablets give you a better representative for the analyte. So it will help you to avoid random error, as you are going to be getting an average of those what I mean by that. If you use one tablet, you might not get accurately because the analyte, there might be a difference between the mass of iron in those tablets. So when you crush them together, you are trying to get an average weight for those average mass of analyte in those 6 tablets. So it gives you room to avoid random error, in kind of in terms of rate determination. So that's that about number one is that it gives you a better mass of the analyte as you are using more tablets, and its concentration is being represented very well in your solution of iron sulfate. So that's that. And then what else again is you are asked to describe how the apparatus was rinsed before. Okay, name the pieces of apparatus used to accurately measure and transfer 25 centimeter cube of iron solution into the conical flask. I've said it is pipette, volumetric pipette, 25 centimeter cube volumetric pipette was used to transfer this into this. So, and how was it rinsed? That was the next question. How was it rinsed? It is rinsed using what? Deionized water. If you want to rinse this now, what you need to do is to add deionized water using wash bottle into it. First of all, you use deionized water to rinse the pipette in order to remove the dust. And the next thing is to use the solution. This solution first. The solution you are trying to pipette out. Use small amount of the solution that you wanted to pipette out to rinse the pipette also, in order to ensure that you don't have diluted solution that you are transferring, because you have already used water to rinse it initially. You want to ensure that the water is being removed, so you use the part of the solution you wanted to pipette out to rinse the pipette again by drawing it out and then pouring it out, so that to ensure that you don't have excess water inside. You don't have water inside the pipette that you are trying to draw it out, because the water can add to the value of the transferring liquid you are trying to use for the experiment, which might affect the determination of the iron content of the experiment. So that's why you have to first of all rinse it with the ionized water and then rinse it with a small portion of the solution you wanted to pipette out, which is iron 2 solution. So this must be carefully done, that you don't contaminate the iron 2 that you are preparing. So meaning that you must pour some portion out into a beaker to do that. So precaution must be taken. And then the next thing was also that explain why the addition of an indicator here now into conical flask was not required. Why don't we, after we've added sulfuric acid and you are bringing this iron sulfate after you have added sulfuric acid there, why don't we add an indicator unlike other experiments? Because when you are carrying out acid-base titration, we usually use indicators like methyl orange, phenolphthalein, methyl red, methyl orange. Why don't we use an indicator here? Because KMnO₄ itself is a self-indicator. KMnO₄ acts as both a standard in standardizing the quantity of iron solution, and also act as an indicator for the reaction. So there is no need for an additional indicator, since KMnO₄ can also act as an indicator. So that's why there is no external indicator. KMnO₄ serves as a self-indicator for the reactions. So now describe what would be observed in the conical flask. In the conical flask, if insufficient acid was present during the titration, explain your answer. I've told you that. Now, the essence of this sulfuric acid here is to prevent F2+ from becoming Fe3+. So if you don't have enough sulfuric acid into it, what happens is that oxidation of iron 2 to iron 3+ will occur. Definitely. And then the reaction, the freshly prepared iron 2 sulfate will become brown because there is insufficient sulfuric acid to maintain the ion to be iron 2. So the essence of insufficient, whenever, in fact, when you discover that the reaction is brown, the best step to take is to add more acid. It does not affect it. You can just add more acid to it to bring it back to iron 2. So if there's insufficient acid, then the solution will turn brown. So when you discover that, you can add more acid to it to reverse the process to iron 2 back. So if there's insufficient acid, in other words, in simple terms, the solution will turn brown as a sort of formation of iron 3 plus. So now let's go into the calculation